Hello and welcome, the Network Berg here. Hope you're doing well. In this video, we'll be discovering route filters, and we'll specifically be looking at how to use route filters with BGP. And this is all for RouterOS version 7. So there has been a lot of changes with how everything is set up. So let's jump into the video. All right, what's going to confuse you the most about route filters is you don't just have this pop-up with all of the information that you can just fill in, like what your destination address or prefix or all of those details are. You are effectively scripting the filters yourself. So this is quite similar to stuff that you might see on a Juniper, which is pretty cool actually, but I know there's going to be a little bit of pushback from some of the community members because people are creatures of habit, and this is definitely a big change or step up in how we tackle filters. So let me just first show you the filters before we actually talk a bit more about them in detail. So I'm just on a MikroTik device now, a little CHR that was on my Eve topology. This is my MikroTik 1. And what I'd like to do is show you where you can get to the route filter. So the option hasn't changed much. You go to your routing, you go to your filters. But the moment you click on this, then you're going to be confused as heck because you're not sure what's going on, because this doesn't look at all what was happening on version 6. So with these route filters, they've actually cut up a lot of the different functions that you might use for a route filter. Here you can see stuff like the community sets. So that you might not use unless you're a bigger type of ISP playing around a bit with communities. But the main thing that I want you to focus on is your rules. So if you go to your route filters, your rule, first tab, this is basically where you'd set stuff like your prefixes and how you can change distances or even apply stuff to the BGP itself as well. So this hasn't really changed, but how you do things with the script or with the filter itself has changed a lot. So if I add a new script, you can give it a name, which is the chain. So that's still kind of the same. So we can call this like in filter. But now we have a big issue. If I click here, there's just a box and I have no clue what I'm doing now. So how are we going to make this work? What's happening here? And this box should actually look very reminiscent of a scripting box, because that is what it is. It's a script. So we are now scripting our route filters ourselves. So you're actually going to have to reference the knowledge base quite frequently until you get very comfortable with the scripting of your route filters. Otherwise, you're going to have a lot of issues. So my recommendation for many of you is on the MikroTik help site, you're going to bookmark that. So I've already got a bookmark on my own Google. So I've got RouterOS this here, help.mikrotik.com/docs. It's this little blue page. Let me just also go full screen. And this typically has all of the information that contains RouterOS version 7 configurations. It's not just version 7, but this is kind of what they're trying to replace the wiki with. But it will help us with our scripting for the route filters. So if I go into my routing menu on this help forum thing, you can see there is actually a filter section. And this, I suggest you read up. Come to this website, read about the routing filters, because there is a lot of things that has changed here, and it explains everything quite well. It also gives you some examples that you can test out yourself to see how the route filters get applied or how you can change stuff. There's even the regular expression stuff that you can start using. Pretty cool. But yeah, I mean, if I go to the first example, like this is quite nice what you can achieve with the script. You can get your chain. And now there's actually, after your chain, this rule equals bit. That is that script actually. So with MikroTik, when you do a script, there's that do equals, and then you do the whole script business. It's just that. But now you're setting a rule in a script format. So what you'll do is you'll state if, and then you'll say what the condition is. So if the destination prefix is this size or this length, then you can set the distance. But what's cool with these scripts are you can use stuff like else as well. So there's definitely a lot of cool, wondrous things you can do. But the downside is it's not very user-friendly to new people that don't understand scripting. And it's also going to be a bit of an issue for people that are used to using filters in version 6 in a specific way, and now they need to adjust to this new scripting format. But who knows, maybe they change things with future updates. Maybe they'll put this all back in the box so you can just tick what you want. But if they don't, this is just how you're going to do the route filters for now. So please bookmark this so you can come here yourself and reference the stuff. And now I'm just going to showcase you a little bit of route filtering on my EVNG topology so we can drop some routes. Actually, there is no more drop. It's a reject or there's an accept. You can't discard the routes. It's just one or the other now. And it's pretty trippy when you reject routes. I'll show you right now. All right, so here we are in EVNG. So I just quickly want to explain the topology and some of the scenarios that we want to run through it so that we can achieve certain things with route filters. Now, let me just explain the topology briefly. We've currently got 3 autonomous systems here. We've got AS 65000, 65100, and 65200. And my goal with the first scenario is the bottom 2 ASs will be redistributing their routes to the AS 65000. But because they're going to redistribute routes, it means that we're going to get some routing information that we not necessarily want. And we're going to use a route filter to reject some of those routes or just accept a very specific route. So that is the first scenario. And the second scenario, I'm going to turn things upside down a bit. And these 2 bottom MikroTiks, they're going to become like 2 ISP routers. And they'll be connecting to the internet. And then I'm going to basically set up failover to one or the other peer in case a drop occurs so that the other peer can just take over, which I feel is a very common scenario in the ISP industry. So this is what we will be tackling right now. And we'll start with the configuration. So the BGP is already set up, IPs are already set up. The only thing that's not set up is the route filters. So I'm just going to get back onto Winbox and I'm going to navigate to my routing BGP. And let's navigate to sessions. And then from sessions, we can verify if the peers are established, what the remote address is, remote AS, remote address family, their IDs, my details, and if there's any filters that's currently being applied, which there isn't. But in theory, what should be happening is my peers should be advertising their routes out to me, my MikroTik, because I have configured the 2 bottom MikroTiks, MikroTik 2 and 3, to redistribute their connected routes, which means they will redistribute this LAN network, but they're also going to redistribute this /30 directly connected route, which is a bit awkward, which is what we want to kind of fix. Let me just show you an example. If I go into my IP routes and I look at the routing table, I can see these 2 routes that I'm highlighting is good. This is what I want to receive. It's those LAN subnets from those 2 routers. But I'm receiving these blue routes as well, which are in essence the directly connected routes. So if you just look above each of the blue colored routes, you'll see it already exists as a directly connected route. So it's kind of awkward because I'm receiving the route as BGP and it is directly connected, but it doesn't affect the routing as much, but it's still not nice to see it in the routing tables. So I could fix this by 2 ways, by either implementing an output filter or an out filter, which would come from the person that's sending the routes. So they can apply an output filter to their BGP configuration to say which routes exactly they want to send out to me. Or it could be an input filter where I am receiving the routes, I've already received it, but then I can tell my router what to do with the routes, because I can tell it to drop the routes, or I can tell it to accept the routes or change certain details in the routes, which is quite nice. Now, what we're going to do is we're going to set up some input route or input filters so that we can just learn. I just want to learn these LAN subnets specifically. So what we're going to do is go into our routing filters, and then in the rule, I can click on the plus. Now we can give it a chain, a name. So we can call this BGP M2 in. And I really suggest being very specific with your route filters. Try and, I'm not going to tell you can't use one general route filter, but if you make one route filter and you apply that to all of your peers, you're going to have issues when you need to make changes to that route filter, and it's going to affect all of your peers. So try and keep it as separate from each other as possible. I'm going to make a route filter for each of my peers. And in this case, BGP-M2 for MikroTik 2-in, it's for its in filter. I'm going to set up a rule. Now, this looks a bit funny because if I look at my documentation, I can see it tells me I need to add a chain, and it's got this rule equals here. So very important that rule equals, it's already been put up in this script box. You just need to start with the script side that you want to run. Now, all that we're going to do is we're going to type in if. We're going to type if, and then we need to say what if. So if, and then destination double equal sign. So if a destination equals, and then that LAN subnet from router 2 or MikroTik 2, which is 192.168.100.0. That destination. So I have a condition now with these brackets. Now we can set curly brackets, which basically sets an action. And in this action, I can type accept. And am I missing anything? Let's just quickly check. It seems like this should be fine. Let's just hit apply. All right, and it took that filter. So now I have a route filter, but the filter isn't doing anything just yet. I still need to actually apply the filter to my BGP peer. So I'm just going to navigate to my routing BGP, go into my connection, go into that specific peer, and then you'll see there is a filter tab. Go into the filter tab, and here's where you can set your input filter or your output filter. So I'm going to set an input filter, select my BGP-M2-in that I created. I'm going to hit apply. And then once I've hit apply, if I go back to my route filter or my routing table, you can see that the route for 192.168.100.0/24 is still active, but the other route has gone into a red state. Now, this is also going to confuse a lot of people because whereas before, if you applied routing filters, you would see that the route just disappears. It's not even part of the route selection process at all. You can't see it. Now, the system is making you aware of the route, but it's telling you that it is on a filter and it is invalid. So it won't be part of any route selection process. It's just going to be red. It's not going to do anything. Now, this is useful because you can still know what the route is, but now it's not going to use any processing power, anything to try and route traffic that way, because the router knows it doesn't exist. It's just notifying you that route won't work. And I'm going to do the same principle or same thing now for my MikroTik 3. So I'm just going to go into my filters. And what's cool is I could even copy this, just change the chain, and then change my destination address. And in that case, it was 172.16.200.0. I'll apply that, and then we can see my second filter is here. And then I can do the same thing in my BGP, just apply it to my input filter. And if I look at my routing table, my connected routes are no longer blue. So I know for a fact those routes aren't active, they won't be used. But I am learning the LAN subnets of the remote side. So this is very useful because now my remote sites can actually still communicate if they need to. And let's just test it out. Let me get onto Eve. Let me log on to this MikroTik 2. So let's quickly see if we can ping 172.16.200.1, which is the LAN IP of MikroTik 3. And I am getting a response. So now I know my routes are still working, even though I have implemented input route filters on my MikroTik 1, which is now basically setting which routes I am specifically accepting. And you can definitely build off of that. You can add more stuff to the chain, or you can add more stuff to the actual script itself to be more granular with what type of traffic you want to allow or stop. But it still works like the old script. It's just, or the old system. You're just doing the scripting part now. So there's no system telling you, fill in this bit to say what you're looking for. So that's the only downside. All right, now let's do another fun exercise where we're going to flip this topology on its head, and we're going to make MikroTik 2 and 3 the breakouts for MikroTik 1, and we're going to set up a bit of automatic failover using route filters. All right, so this topology has now been flipped on its head, and now MikroTik 1 will be using MikroTik 2 and 3 as potential ways to break out to the internet. Now, we've got a bit of a situation, because if I log on to MikroTik 1 and I look at my IP route print, both routes can't be active at the same time unless you're doing some ECMP type of stuff. But that's not what we want. We want an active passive type of failover setup so that if the one link goes down, the other one takes over. Now, let's say we actually wanted 192.0.0.2, this gateway, to be the primary gateway. Our issue right now is currently both routes, they get received from both of the peers, and many of the details are basically the same. Even the distance is the same. So there's no way for my MikroTik to just say, okay, 0.0.2 is going to be the preferred route. It's not like you select it that way because the route selection process is happening in the background, but we can affect that selection process by using route filters. Now, there's a couple of things that we could do, but the most easiest thing for us to do is set up another input filter, but we're going to do things like change the distance so that one distance is a bit lower than the other one, but we'll also add some stuff like BGP weight so that when the algorithm and when the route selection process takes place, it can see, okay, this one is heavier than the other one, so we're going to prefer this one. All right, so let's look at how we can achieve that so we can get a form of failover on our links. Let's just also verify that we can actually break out. So let me see, can I ping 8888? Yes, I can. So now let's set up those amazing filters. And this we're going to do through the command line now. So it is routing filter rule. We're going to add a rule. Remember, we need to specify a chain. So let's just call this primary. Then we need to set a rule equals. Remember that box was that rule equals. And now we can start to populate the rule with information. So now we can set stuff like a condition. So here I'm going to say the default route, and I need to set that as DST equals. So I'm going to say the default route that I receive. What am I going to do with that? I'm going to do a specific action. Ooh, I hate when the command line does this on version 7. So I might just quickly copy this onto Notepad and then we'll just edit it further from the Notepad. So I'm just going to open up a new Notepad there. So routing filter. Sorry, let me see if I can zoom in a little bit. Zoom. There we go. That should help. So routing filter rule, add chain primary rule, our condition, and then our action. So that is the curly brackets. And then with the curly brackets, we can specify a set, and then we can do distance. I think it might be distance, but let's just go back to our documentation because you are going to come back here a lot to reference this to actually make this do what you want it to do. So let me just scroll down here. Distance, set destination, set distance. Set distance. Okay, so set distance. It's just that set distance, and then what we want to make it. So I'm going to make that 5 for the primary, and I'm going to also do another thing. I'm going to set, and then we're going to set a BGP weight. So I need to just find that. So that is going to be BGP weight. So I can copy it even from here if I want to. And that I'm going to make 2000. And then there's one more action that I want it to be accepted. So let's just copy this and see if I paste this into my command line, if it actually takes it or not. Hopefully it does, because then this is a pretty good video. So let's just do this. I'm just going to backspace. And let's do this. Copy, paste, enter. Oh, I didn't specify an if. So that is definitely going to make an issue. So let's just type there if. And was it an if with the space? Just see, did it take that? It looks like it took that. Routing filter rule print. So here I've got my primary chain that I created, and the rule says if the destination is the default route, set the distance to 5, set the BGP weight, and accept it. All right, so that's perfect for me. And what we'll do is let's add a secondary route as well. Let's just call this chain secondary, and then the rule will be the same. The distance, I can leave that blank if I want to, because the distance with the BGP or eBGP is by default 20. Let's just set the BGP weight to something else like 1000, and we'll accept that as well. And I'm going to copy this now and put this in my command line. And that was taken without any issues. So now I've got 2 route filters, but I still need to apply these route filters. They're at the moment not really doing anything. So what I'm going to do is routing BGP connection. And remember, I've got 2 different connections. So with 2 different connections, I need to set my 2 different input filters. So routing BGP connection, set input.filter equals, and then I can make this primary. And my primary is going to be this gateway to 0.2. So I can set that as 0. And my secondary will be my second peer. And now if I do an IP route print, I can actually see that it has updated. So now my top route is the backup, and the other route is now the primary route. And we can see that the distance has been updated and it is being preferred now. It is currently the active route. So we've actually set up 2 links that's coming into a single router to the internet. And now if one of the links goes offline, the other link can just take over. So let's just test this in practice and see if this actually works. So what I'm going to do is I'm going to log on to, I'm actually not even going to log on. I'm already on MikroTik 1. So I'm just going to run a continuous ping to 8.8.8.8. And we can see we are getting a response. And what I'd like to do is I'm going to turn off the BGP peer for MikroTik 2. So that will then trigger an emulation of the link going down. So let me go on to MikroTik 2. And all I'm going to do is go into my BGP, turn off the peer, and let's even turn off the interface. Actually, let's even shut down the device. So I'm going to shut down MikroTik 2. Let's go back onto the command line. And things just kept going. So it's not normally this flawless with BGP because you do have stuff like a whole timer, and me turning the peer off kind of just forced it to go on to the other route. But if I do an IP route print, we can see now it's only got that route for the secondary link so that it failed over. And bringing it back up is as easy as just running my ping, turning back on the other router, and turning on the BGP. So let's reconnect. I'm just waiting for the router 2 to come back up here. There we go, router 2. And I'm just going to navigate to my routing, navigate to BGP, re-enable that, see if my session is up. Session is up. Let's look at the command line, and we can see it's still pinging. Whoop. Still pinging. And let's just do that, do an IP route print, and we can see the primary route is actually out of 192.0.0.2 now. Cool. So failover is working, and we achieved that with some input routes as well. So this is just, again, very basic introduction to route filters with BGP on MikroTik, because this rabbit hole goes very deep. I can promise you there's cool stuff you can do with BGP and route filters, even with the OSPF. But I just wanted to give you a taste and show you how the route filters have changed from version 6 to version 7, because now it's all scripted. Cool. So I'm going to end off the video here. I'd like to thank you guys for watching. I'd like to thank the people that sponsor this channel on as YouTube members as well as on Patreon. You guys help really help the channel out so much. It's allowed me to get some extra stuff like extra lighting, stuff like my green screen and my new face camera of the Elgato. This is what I use the YouTube money for. So thank you so much. And I'll catch you guys in the next video where we might dive into some more BGP topics, or we will do some other things. Leave a comment. Tell me what you guys are interested in seeing. See ya.